and welcome to another episode of the Fresh Thinking by Snowden Optiro podcast, a podcast where we delve into the technical aspects of the mining industry. My name's Tarrant Elkington, General Manager for Snowden Optiro here in Perth. I'm joined again today by Markus Dammers from Metso, joining us from Germany, but here with us in Perth today. Markus has more than 15 years of experience in the mining industry across multiple OEMs and is the director for IPCC and crushing and conveying for Metso globally. So Markus, great to have you again on the podcast.
Thank you, Tarrant.
So in the past, we've had a few podcasts talking about IPCC or in-pit crushing and conveying. So please go and have a look at those. I thought while we've got Markus here, we might just talk about some of the topics that maybe people don't understand or should be thinking about when it comes to assessing IPCC for their operations, and share some insights both from the equipment and from the mine planning perspective. And Markus is a great person to talk to that about. So we'll cover bounce around a few different topics and ideas and see where we go. But the first one I thought we'd talk about is really what we've thrown around this word IPCC, as a catch-all for this space. But in fact, IPCC is not always in the pit, right? That might not always be the best solution, right? And then it gets a bit weird. So what are your thoughts on this, Markus?
Yeah, in all these years, I mean, the acronym IPCC, has a place nowadays in the industry, so that's fine. But what I see is it is an umbrella term for many things, right?
Yep.
So it is on the one hand you have, it's manifold, but you have many semi-mobile, fully mobile systems. Sometimes people talk about fixed IPCC as well. Something I would disagree in a way, come to this later. And then you have always the ore and waste part of it, right? So, and then very quickly, semi-mobile IPCC is about having relocatable equipment in the end, crushing plant and conveyors, which can be relocated from time to time. I'm not talking now every other year, 2 years, 3 years. It is really every 5 or more 10 years, more strategic thinking. That is not something you would do very often. Then fix is fixed, clear. That's permanent infrastructure. If you want to remove it, it has to be demolished or disassembled. And then you have fully mobile IPCC systems or truckless IPCC systems, as many say. And here you have really a mobile crusher or crushing plant, which is directly fed by a shovel and fully eliminate trucks. And this, in the end, something which in all of the cases in hard rock metal mining is hard to overcome. We can elaborate on this a bit later, but that is a spectrum in the end we are talking about. So again, what is IPCC about? It is reduce the truck fleet, so the number of trucks, and not eliminate the trucks really, right? So there's always a sweet spot we have to find, and that is the idea of this concept in the end.
And I think that people think that IPCC is this special thing, but in reality, every mining operation in the world crushes and conveys its ore. That's a necessary. Well, most of them do, right? So it's a very common thing and implemented in every operation. The only thing that what we're really talking about here is just where do you put, for ore at least, where do you put that crusher? Do you move it closer to the mine so that we can reduce the length that we need to haul to by increasing the length of our conveyor? So I think people's misconception maybe is that this is a niche thing, but it's actually a very common thing, in the industry.
I think here the main point is the following. People thinking about the standard which we are talking about, it is very often fixed infrastructure, concrete plant, fixed conveyor, or sitting on maybe not steel or concrete precast concrete sleepers, just on foundations. It is fixed. So the shift from a fixed installation to a semi-mobile installation is not big. That actually it is the same. Just another thinking. You have more steel or precast concrete compared to a concrete plant and an infrastructure project you're doing there, right? So that is one thing here. I think is really really important to understand, in my opinion.
Yeah. And I think one thing I always have in my mind is, is IPCC the right word for what we're trying to do? Is really we're just trying to reduce our trucking, right? So would a better, by replacing it with conveying, would a better terminology be that we're doing strategic conveying, right? Where we're not just doing the simple solution of coupling our crusher with our plant. We want to actually couple our crusher with our mine, because we want to minimize the haulage that we have, and there's no necessarily reason that we need to couple the crusher with the plant other than for convenience.
Yeah, exactly. So the primary crusher and the conveyor are tools for mining engineers, right? So
Yeah.
Yeah, in the end, strategic conveying is maybe a good word, or a good term, because it comes along with strategic mine planning, right? So long-term mine planning. You need a vision. It is not about next week, not short term. It is really strategic. So yeah. So maybe you can change the name.
Yeah, you never know. We'll see. We'll see if it takes off. But I think that's that conveys to pardon the pun, the intent of it probably in a better way than IPCC. But we'll talk a little bit more about going in pit in a moment. Maybe we'll come to the point now on fully mobile IPCC or truckless IPCC. What's your experience or views on that?
Yeah, truckless or fully mobile IPCC, what I see is the following. It is really coming from the coal mining industry. That is one aspect out of this. Why? Because in coal mines, really, you have more regular shapes in the end, right? So it's strip mining arrangement, horizontal development all the time. It is not, and the great variation. I mean, what's a great variation? It's for sure it's optimized, but it's not that much as you have in a hard rock metal mine. So there was always a try to get it from this coal mining industry into hard rock mining. The problem is that if you think about it, in a fully mobile setup, every shovel needs its own crusher, and its own crusher needs its own transportation system outside the pit, or at least to a central, assembly point or transfer point where several shovels come together to one major X-pit conveyor. Yeah, and that is really that is the hard part of fully mobile IPCC systems in hard rock. So we see some applications for smaller capacities where you do not have so much grade variation. That sometimes it's possible, but if you really talk about high capacities where you need, also from a crushing technology point of view, like gyratory crushers, it is hard to put these crushers on a mobile rig. So there's so many complications. Plus, then you have all a chain of smaller conveyors going to a central point in the pit on a bench setup outside of the pit. That more or less, destroys the whole value. And if you want to increase value, what we all want to do, that is really,
And if you want to add to the mix, if you have different material types, if you have waste and ore, on a bench or within your mine, which most mines do, it starts getting tricky, right, to say the least.
Yeah, and And you also have, so you have an efficiency problem with your fleet. So you will quickly see if you plan for it. And we also have been involved in those, and I did it many years. If you plan for it and really in a study you make it, you see that the overall equipment efficiency of these systems drops below 50% maybe. So you have to tell management later, okay, we buy such a system, fully mobile system, eliminate all trucks, but the gear you have in place now is only operating less than 50%.
Mm.
You know, it's just, it's complicated.
Yeah. And I think that, trucks, everything always comes back to trucks being an important part
Yeah.
of the process.
It is.
They give you a lot of flexibility to
Yeah.
decouple your loading from your
Yeah.
materials handling system,
Exactly.
right? And so I think, and so I think what we're in sort of violent agreement about is that, there's still a path for this IPCC, but
Fully
it's
mobile.
it's really hard,
Yeah.
to go fully mobile.
Yeah.
That there's still a lot of, and if you go back to our previous podcast, a good, value proposition, say for ore, putting your a crusher in pit at the top of your ore, or somewhere around
Yeah.
the top of your ore, or the, in that area, or in waste, putting it, at the pit rim, or something like that. So on top of where that material is, because you're going to be hauling upwards,
Yeah, I mean, for smaller capacities, I have to say, in quarries or so in
Yeah.
aggregate industry, for example, we have a lot of systems, and it works, right? Especially aggregates, you do not have this, optimization potential that much as you have in hard rock metal mining. But even in smaller applications, we have some iron ore applications. Yeah, all this can make sense, but it is really then in smaller capacities where standardized small crushing units, like that's in our case local trucks, geared up with jaw crushers. Yeah, that are smaller systems. Okay, that has its place as well. But we are talking now more on the big mines, the higher capacities. Then really becomes a problem.
Yeah. Maybe we can move now to the other topic you brought up, was in pit. And so I think, there's some complications, right, of going in the pit that I think some people miss in their evaluations.
Yeah, so we had this topic in our previous podcast when we talked about the rapid screening tool we developed. In pit is really it comes with some complications. One is really you have additional waste stripping. That's a big topic because you have to place your conveyor and the crushing plant in the pit. Then I think one important thing is really the mines, how they are optimized nowadays, and the tools we are using in mine planning, strategic mine planning, do not have all the, let's say, constraints necessary to do a proper evaluation all of this. Yeah, so I mean, it improved maybe a little bit, but that is really to do a proper analysis and study needs a lot of, let's say, handwork. I would say it's not so automated if they have just trucks, right, where you work with factors, everything is known, everybody knows it. The programs, the software packages are geared up exactly for this. But if you want to bring in some conveyors and want to run scenarios, still a bit of handwork to do. Or how? What's your take on this one?
Yeah, I think it's a spectrum. So if you have a pit rim crushing or close to the pit or ex-pit, then you can continue mine planning in exactly the way you can. Generally, you could just follow the mine plan that you want to follow.
Sure.
I mean, lots of people do talk about, when we go into the pit, there's a lot more complexity that comes into the mine planning to make that work. Your haulage network internally within the mine. So you just don't need to get the pit to exit to a point, out of the pit towards your crusher or your waste dump, but you need to now bring it towards the location of wherever you put that crusher. It's much harder to locate it centrally in a place that it can stay for a period of time. So I think these are some of the things that need to be considered. I think some people would naively think that if I put a crusher into the pit, I'm always going to have a haul path that the deeper I get it, the more saving I'm going to get. The deeper you go, in addition to the excavation cost, which can be enormous, and I think lots of people that do implement this don't consider that. They're just like it's an assumed cost. But the haulage network gets a lot more complicated. So as I go deeper, there's more potential that you need to take the haulage network up and then down and then up, when you're connecting various cutbacks. So yes, there's no single tool that would help you do that. The other thing I would say is that typically the savings we're going to get out of materials handling solution is a reduction in cost, right? Often the greater benefits we can get is in higher throughput or more revenue. So ideally what we want to do is that we want our mine plan to be optimized for value, right? So the more that the materials handling system impacts on your ability to follow the optimal path through the deposit, the more that's going to negate the actual value of the system. So we want to try to get that right balance between, trying to follow the maximum value path through the deposit, but trying to minimize the mining cost by strategically locating the crusher in the right position for that mine, right? That's these are the things that need to be considered. What if you've got multiple pits? There's no point in putting the crusher in the pit. You'll locate it somewhere
if you have one
between them, right? Yeah. If you have one, or then you need one for each pit. But then you're going to have lack of utilization of one, potentially overutilization of another, so that becomes tricky. All of these things need to be evaluated, right?
Yeah, exactly. But do you see, especially in the software development side, is there more flexibility now when you set up, when you do when you transfer from your geology model, so into an economic block model to the whittle or whatever, is that more flexible nowadays, or?
Yeah, I think it's difficult from an optimization perspective. From a design perspective,
No.
I think there's the automation of the mine design tools are getting better in the industry over the last 10 years, for sure. So there's the ability to put in cut in a little rectangle or add a conveyor line or whatever, and have it be able to quickly evaluate the change to the mine plan. But from an optimization perspective, I don't think there's anything that takes into account the additional waste that you're going to have to take in that particular location, or that will tell you where you should put the crusher, right? That comes down to
I saw a lot of research papers the last years coming out on this topic. I mean, it's research. I did not see it on software packages, but do you think we are missing something here, or?
Well, I guess it depends how common it becomes that we go into the pit, as to whether the major software companies come in. But I think the first step in that is actually finding in the research, is finding a way to do it, right? Or what are we actually trying to do in doing that? So I think that's encouraging that people are looking at it, and I'm very interested. But I think to get the attention of major software, there needs to be a solution and the demand for it. Yeah, yeah. Maybe we can move on to talking about the lead times for this equipment. So, like everything in the industry, these capital projects, get more expensive. They take, so often longer than we might anticipate, right? Due to various factors. So, where do you see, those things in the industry?
Yeah. So one of the initially, let's say, challenges IPCC concepts have is not only the lead time, it is the overall evaluation plus lead time, right? And that is the reason when I see when we do studies, this is always set up as a major infrastructure project. It takes very long time. So I think this part has to be reduced, and then on the project delivery, so engineering, procurement, and the supply of all these systems, there is also some, let's say, there is some potential to reduce it. So what we do, we really productized our offering when it comes to crushing plants and conveyors. So we have design standards for our own design standards, but can be justified to the local conditions in the end. It's needed. But still, when we have these standards available, that enables us to help in feasibility studies, and making the feasibility studies really more efficient. We can right away we come up with different scenarios, budgetary pricing, feed engineering companies or consultants, as you or mining companies, with this data, and they can go through the conceptual scoping, maybe even PFS stage rather quickly, and that is the reason why one of the reasons why we have the standards and productized offering nowadays. And then on the supply side, we really save time in engineering, right? If that what we would like to see is here we have this offering, we offer mining companies in the end, hey, just take it. That's it, right? So that is your potential solution. If you go like this, kind of 80% this, you're good to go. There is only minor adjustments to do, and then we quickly go into procurement and delivery of the systems. Here we are lacking some time, and I would like to see this a bit more, of course, right? It is because on the other side, if you look at truck and shovels that are also products, you cannot compare this, right? So I will not compare a truck with a crushing plant. That is an invalid comparison. I agree, but at least some standardization and modularization, as we tried, that would help, in my opinion, really to speed up the whole process. So that nowadays it really depends and on the length of a conveyor line, so it's hard to say. But all these projects from if you push the button kickoff meeting until commissioning in operation is a 2-point-something 3-year time frame. Can be less and more, depending, on especially length on conveyors and how much you have to supply. But you can get really a couple of months out of it. Just go with standard approach, be fast, do a decision making.
Yeah. And I think by getting the lead time, it gives more ability to people to make decisions closer to when the benefits are going to be realized, which is actually quite an important thing in a dynamic market. But I think and one of the key things as well is that people need to be thinking strategically. It's not just about meeting this year's budget, but what's happening in 5 years' time. Is your materials handling going, requirements going up? Are you going to need to buy more trucks anyway, which would make an assessment like this more appropriate? So I think that's something that people often miss is, there's some things that are going to have 10-year lead time. We need to be thinking about them now, 5 years, 3 years, we need to have a master plan for a site, and that's quite important.
Yeah, one angle here is also, so look, we tend, when it comes to a conveyor or a crushing plant, we tend to optimize in feasibility studies or bankable feasibility studies before it's kicked off. We tend to optimize really every single piece of it. Yeah, and I really, to save what, 1 million or 2.
Yeah,
it is what we are talking about. It is not so important in the end, right? Because we also do not go to a truck manufacturer and say, it would be better to have the 340-ton truck, right? So
345.
Exactly.
Yeah.
Because anyhow, the material properties change anyhow. So the match of truck and shovel is never perfect, only on the paper, right? So the swings you need to fill up a truck is never always the same. Or if it's the same, it's not always the same load. So, but we accept this as an industry, right? So I would like to see a bit more pragmatism, also on the downstream side.
Absolutely. Makes sense. The final topic we wanted to have a quick talk about was around decarbonisation and its, the role that IPCC plays in that electrification, decarbonisation part of the world. and we know that we're generally trying to convert trucking to conveying. We're trying to convert diesel to other sources of power. Hopefully, if that power source is a renewable source, then you would get you would get clear carbon emission savings. But one thing that I've found is that people want their cake and eat it too, right? And that they want their current base case business plans to look good, right? So they don't want to bake in, increasing diesel prices, increasing like costs of emissions and things like that. That would make IPCC look more
Huge difference there.
Yeah, more appealing, right? But they also want the emission savings. So you're sort of locked in this challenge of getting the inputs right, and to try to give the most balanced view of the economic and environmental savings attached to IPCC, right?
Yeah.
You think that like if you've got environmental benefits and economic benefits, then it's kind of a no-brainer to go ahead with it.
Yeah.
Right. If all you've got is environmental benefits, but the economics don't stack up because you want to assume that diesel prices are coming down, over the coming years, which we haven't seen, any evidence of, or that there's going to be no cost of producing carbon or whatever, then that's fine. But it does kind of lead you away from some of these initiatives, right?
Yeah. That's always interesting. It's an interesting point you mentioned, especially in the final stage of a study. Let's say the owner or study manager has to decide on the inputs, right? And especially one important point is of course the diesel price and related carbon and all this. So that is always I see as well a hard topic to overcome.
Yeah.
But also it is interesting. So now we are podcasting in West Australia. How are the diesel prices developed over the last year? Are they growing, increasing, or it's flattened out, same as 10 years ago?
Yeah, I think in Australia, I think we have quite low diesel prices,
Exactly.
relative to the rest of the world, but also generally less access to renewable, and low cost power sources due to the remoteness. So it's a balance of those things, right? So I don't know. Elsewhere in the world, I think it's probably much more expensive for.
It is much more
diesel.
expensive, but what I see when in forecasting and studies where I've been involved, so I do not know everything, but in it there is kind of I would not say it's going down, but it's not going up.
Yeah, never
right.
going up.
That is somewhat interesting.
Yeah. It's like there's the ability of the mining company to drive costs down by getting cheaper diesel when it's linked to the market. But I think it's it's an interesting topic, I guess, for people to think about when they're evaluating these things. Right?
But how do you see the ESG debate nowadays going on? Because there was always a big push that there were times, but we have to reduce OPEX. That was a big driver for conveying in the end. Still is. I mean, that is the biggest driver, I would say.
Yeah.
But there was a major push the last years, or especially around COVID. That was my personal impression.
Yeah.
How do you see it?
But I think it was at one point ESG at all costs.
Yeah.
Right.
Exactly.
And now I think it's try to pursue these initiatives, but try to make them economically viable or palatable.
Yeah.
You can't just do it at any cost. There's still, you still need to stay profitable to be able to afford to put these measures in to make these changes. And I think that's kind of the way the world's headed to a more pragmatic, view of that world. I don't know if that's what you see as well.
Yeah. So there has been a trend, I would say, and in all the studies where we have been involved, that mining companies would allow for a lower IRR when it comes to carbon saving technologies.
Yeah.
So as a potential enabler to get them to life, right? So
and maybe linked to the thought that they could get a lower cost of capital as well, for funding sources for those. And there are grants available from governments and things that can be considered too. So I think there's things that, that these are interesting things that we'll see how it goes into the future. But I think we might wrap it up there. I think there's some really good topics that we've gone over. So thank you very much for joining us, Markus.
Thank you very much.
And I think, if you're interested to know more about IPCC or strategic conveying, please feel free to get in contact with myself or Markus. And if you enjoyed the podcast, please subscribe to us on all good podcasting platforms. And we look forward to speaking to you on the next episode.